Good morning, students. I, Mrs. V.A. Yavle, Assistant Professor in Department of Electrical Engineering, AISSMS, IOIT, would be discussing with you all today the output equation of a single-phase transformer. Let's see how the derivation is carried out. Good morning, students. Today we will see the output equation of a single phase transformer. First, let us understand some terms related to it. If I draw the schematic for a single phase transformer, right, this is the area of the window. This distance is denoted by capital D, which is known as the distance between the adjacent core centers, right? So, the voltage induced in the winding which has T turns and is excited by a source having a frequency f hertz is given by Et could be E upon T, which is a general equation, which is 4.44 F phi m. As we can see from the schematic of a single phase transformer, it has one primary and one secondary winding. Therefore, the total copper area in the window, the symbol for which is capital A subscript C, is given by copper area of primary winding plus the copper area of secondary winding. Now, how will we get the copper area of primary winding? If we know the primary number of turns and area of primary conductor, we would be able to calculate the copper area of primary winding, right? So, the number of turns of primary winding denoted by capital T subscript P. Let us assume that the area of the primary conductor is AP. Similarly, we can find the copper area of secondary winding, which is given by TSAS. Therefore, we get this expression that AC is equal to TPAP plus TSIS. Let us consider that the current density is delta, both for primary as well as secondary winding. Therefore, AP will be current in the primary winding divided by the current density, and AS, that is area of the secondary winding, will be current in the secondary winding divided by the current density, right? So, we can replace these values of area of conductors in, let's say, equation number 1. Therefore, AC can now be written as TP IP upon delta plus TS IS upon delta, which finally comes out to be 2AT upon delta. we can mark this as equation number 2, where AT is nothing but TPIP is equal to TPIS, which is considered same for primary as well as the secondary. Now here we have to see a new factor or a constant which is known as the window space factor. It is denoted by KW and is nothing but the ratio of copper area in the window to the total area of the window. Therefore, we get that copper area in the window is KW/AW, which is nothing but equation number 3. But equation 2 and equation 3 both are giving us the value of copper area in the window. So let's equate equation 2 and equation 3. When we do that, we get 2AT upon delta is equal to KW/AW. Therefore, we can just rearrange this equation and get it as KW/AW delta upon 2 is the equation for ampere turns. Let us mark this as equation number 4. Now, because we want to find the output equation for a single phase transformer, right? So let's know the rating of a single phase transformer. We know that it is in kVA, right? And it is given by Q is equal to VPIP into 10 raised to power minus 3. This 10 raised to power minus 3 comes because we are going to convert it to kVA, that is the standard unit. So this can be written as EPIP into 10 raised to power minus 3, considering that the voltage in the primary is equal to the EMF in the primary, which can again be replaced as EP can be written as ET TP IP into 10 raised to power minus 3. But number of turns and the product of current is nothing but ampere turns. So I can very well write it as ET AT into 10 raised to power minus 3. Taking the value of AT from equation 4. If we refer the earlier equation, right, we can rearrange this equation that Q is equal to ET KW/AW delta upon 2 into 10 raised to power minus 3. We already know ET is nothing but 4.44 F phi m. So this can be, it is now just a rearrangement of the terms KW/AW delta upon 2 into 10 raised to power minus 3. So I can cancel this 2 with this. So I'll get 2.22 F phi m KW/AW delta into 10 raised to power minus 3. Q is equal to. But we always know that flux is nothing but the product of flux density and the area of iron path. Therefore, putting this value of flux in the above equation, Q comes out to be 2.22 F Bm delta KW/AW AI into 10 raised to power minus 3 kVA. Right? So, this is the output equation of a single phase transformer. So I hope you have understood the derivation that we have taken today, where Q is equal to 2.22 F Bm delta KW/AW AI into 10 raised to power minus 3. Thank you.